My friends, we are almost there, I promise. We have just one more thing to look at, and that's our auto-scaling groups. We'll deploy two auto-scaling groups for the web and application tiers. Within each group, auto-scaling will be responsible for launching and configuring the EC2 instances. Auto-scaling will launch a certain number of instances into each group, and that includes installing the application components. It is going to add the instances to the load balancer's target group, and it will terminate and recreate any instances that are unhealthy. For the web tier, auto-scaling will monitor the average CPU utilization of all the instances in the group, and it will scale out. That is, it'll add more instances if the utilization gets too high. Likewise, if the average CPU utilization falls below a certain threshold, auto-scaling will scale in by terminating unneeded instances. All right, let's jump back over to the app stack template. Right around line 155 is where we define the auto-scaling group for the web tier. Whenever auto-scaling launches an instance, it uses a launch template. In this case, web server launch template refers to the name of the template resource that auto-scaling will use. Let's take a look at this. Jump over to line 195, please. The launch template contains all the details needed to launch the instance, including the AMI, the instance type, and the security group. More importantly, though, it contains a script to install the application components. Jump down to line 205. We want to automate our application configuration using a script that will automatically execute on each web tier instance when it launches. The user data section contains a Linux bash script that's going to do several things. First and foremost, it will install Docker. Docker will then download an image that contains the application, which again is just a web server, and it's going to run that application in a container. We're going to point the web tier instances to the application tier load balancer URL, which will be listening on port 8080. Now let's take a look at the diagram again. Recall that the web tier instances connect to the load balancer in the application tier to reach the instances in the application tier. All we're doing is passing the application tier's load balancer URL to the instances in the web tier. Now, please don't worry if you didn't catch all that. Once we deploy everything, it will start to make more sense. Another thing that the user data script will do is install the CloudFormation Bootstrap package. This package includes the CFN-signal executable that talks to CloudFormation and tells it that the instance launched successfully. Now, why does CloudFormation need to know that? Well, it needs to know that the auto-scaling group is working. If our instances all launch and execute this CFN signal command successfully, then we can be pretty certain that the auto-scaling group is working. On the other hand, if no instances launch, then that's a pretty good indication that either the auto-scaling group wasn't created or configured correctly, or that we've bumped up against a service limit. So this is just a feedback mechanism to ensure that we don't end up with a stack that has a non-functioning auto-scaling group. All right, let's jump to line 154. Here we set the minimum and maximum number of instances for the auto-scaling group. Auto-scaling will ensure that the number of healthy instances never goes below the minimum, which is 2. Likewise, it will make sure the number of healthy instances never goes above 4, the max size. Even as we're scaling in and out, auto-scaling is never going to go outside of these bounds. In a moment, we'll look at the scaling policy that controls when and how scaling occurs. Now, when CloudFormation initially creates the auto-scaling group, it begins with a certain number of instances. This is called the desired capacity. If we jump to the parameters section on line 54, the desired capacity is 2. So we're going to begin with 2 instances in the web tier. Now, there's a potential point of confusion here. Notice the min value and max value listed. This is a parameter constraint. When you deploy a CloudFormation template, you can pass in parameter values to override the default values in the template. This constraint simply limits the range of values that you can pass in. To be clear, these values are not the minimum and maximum values for the auto-scaling group size. Okay, let's jump to line 160. Here we go. Now, auto-scaling will add instances to the internet-facing Elastic Load Balancer's target group. Once those instances are added to the group, the load balancer will start doing health checks against them. The auto-scaling group will then use those health checks to determine whether the instances are healthy. For example, if the application crashes on an instance, the ELB health check will detect that and autoscaling will terminate that instance and launch a new one to replace it. By the way, the health check grace period defines the number of seconds that autoscaling will wait before it starts paying attention to the results of health checks. This is to prevent autoscaling from prematurely terminating a newly launched instance that may not be fully operational yet. There's one last thing we need to look at, and that is the scaling policy. Let's go to line 230. The scaling policy we're going to use is called a target tracking policy. The autoscaling group will try to keep the average CPU utilization of all instances in the group at around 75%. If the average utilization goes above 75%, autoscaling will add more instances. If it goes below 75%, autoscaling will remove instances. But remember, autoscaling will not take the number of instances outside of the bounds we set. The number of instances in the group will never go below 2 or above 4. Now, because we're starting out with 2 instances, we should remain at 2 instances unless the CPU utilization of our instances goes way up, and I do not expect that to happen. By the way, you can use a target tracking policy with other metrics, not just CPU utilization. For instance, you can scale based on the number of messages in a simple queue service queue. Think back to the beginning of the course and the example of a video processing application. In that scenario, if the number of messages in the queue gets too high, you could have autoscaling launch another instance to handle the additional load. All right, finally, let's go to line 340. This is the autoscaling group for the application server tier. Now, I'm not going to go through this because it follows an almost identical pattern to the web tier group. The one difference I want to point out is that we are not going to use an autoscaling policy for the application tier. The group size will be statically set to 2 instances, and it will stay that way.